Hello students, so we are doing revision. Today we are going to solve problems based on continuity, okay, and these questions are asked for 3 marks, okay. We'll just solve some of the questions. So this is the question which is given. It is given that function is continuous at x equal to 0. So what do you mean by continuous? Its right hand limit is equal to left hand limit, and it is equal to the value of that function at that given point. Okay, so here the given point is x equal to 0. So you have to find f of 0. So first we'll find the limit. Okay, so at limit x tending to 0, 3 raised to sin x minus 1. So this is limit formula we have to apply, that is a raised to x minus 1 upon x. Okay, when limit as x tending to 0, we'll get the answer as log of a, right? So this we have to apply here. So we need here sin x square. Okay, so we'll divide and multiply by sin square x. Okay, now the second term in the denominator is x log 1 plus x. Okay, so x I'll keep as it is. Log 1 plus x, I'll write it as 1 plus x divided by x multiply by x. Okay, so this term we can write it as limit x tending to 0, log of 1 plus x. We can take this x here, so it becomes log 1 plus x raised to 1 by x, okay, which is nothing but log e. So we can directly write here. Now this is x square, right? So that x square I can write here. It is in the denominator, correct? So we have all the limits. So this becomes your log 3 square, okay, into 1 divided by log e. So the final answer is log 3 square means yeah, this is the final answer. Okay, so and this is your f of 0. Okay, this is the question which is given. Now your function is defined in 3 ways. Okay, for this is for x less than 0, this is for x greater than 0, and at x equal to 0 it is half. Okay, and the information which is given is f is continuous. Okay, f is continuous at x equal to 0. You have to find a and b. Okay, so you have to find the limit, left hand limit and right hand limit. Okay, so LHL will be limit as, this becomes your LHL, limit as x tending to 0 minus. Okay, now here again you have to apply all the formulas, limit formulas. Sin x upon x into x I'll do. Okay, now for log 1 plus ax, again I need x into x. Okay, and then we have 1 upon 2x square. Okay, now this term becomes 1 when x tends to 0. this term becomes log e raised to a. So this is your a. Okay. Now this x into x will be x square, and this gets cancelled with this. Okay. So you'll get the final answer as a upon 2. Okay. So this is your LHL. Now we'll move on to RHL. Okay. I'll write here LHL. I'll write here a upon 2. Okay. Now RHL, right hand limit as x tending to 0 plus. Okay. Now here 1 minus root of cos bx upon 2bx square is given. Now I am rationalizing it. So this will be 1 plus root cos bx upon 1 plus root cos bx. Okay. So your numerator becomes 1 square. This is a minus b, a plus b. So a square minus b square. So 1 square minus root cos bx the whole square. So you will get cos bx. Okay. Upon 2bx square into root 1 plus cos bx. Now for this you can use the half angle formula. Okay, 1 minus cos x is 2 sin square x by 2, right? So you can write it as limit as x tending to 0 plus 1 minus cos bx is 2 sin square. Now here our angle is bx by 2. Okay, upon, this is already there, bx square and the term in the bracket. Okay. Now this 2 and 2 gets cancelled. To make this 1, we need 2 here, right? Here. Into 2, divide by 2 and into 2 I'll do. So this becomes your 1 when x tending to 0. So, and then you can substitute here also 0. So this will be cos 0, which is 1. So this is 1 plus 1, 2. So 2 into 2, 4. So the final answer is 1 by 4. Okay. So your RHL is 1 by 4. Okay. Wait a minute, you need B also, right? Yeah, here you have to multiply, you have to make this square because here square is there, so you have to make it square. Sorry, so you have to divide and multiply by 4, and also you need b square, so multiply by 4 b and divide by b. Okay, like this it will be. So that b I'll write here. Now this becomes 1. Okay, and what remains is, this is your 4, 2, 4 to the 8. So 1 upon 2 by 8 by b remains. Okay, so the final will be b upon 8. Okay, b upon 8. Otherwise I'll solve it here. See, this is what remains, sin square bx upon 2. Okay, upon we had bx square. Okay, so we need here 4 because this should be in the square form. So I've multiplied by 4, divided by 4. Again we need b square, b. So b square, so you have to divide by b. Now this becomes 1. And the term which remains here, this becomes 2 1 plus 1 2, so 2 4s are 8, so this is 1 upon 8 by b, which is b by 8. So this is our RHL. Now you can equate RHL and LHL to f of 0, okay, because f is given continuous. Since f is given continuous at 0, okay, LHL is equal to f of 0 is equal to RHL. Okay, so f of 0 is half, LHL is a by 2, which is equal to half, so we'll get a as 1. Okay, and then equating it to RHL, you'll get b by 8, right, equal to 1 by 4. So this is b equal to 8 by 4. So b is equal to 2. Okay, let's solve this. So this is the function which is given, okay, and it is given continuous at x equal to 0. You have to find a and b. Okay, let's solve. Now this is your x greater than 0, so this becomes right hand limit. Okay, so limit RHL, limit as x tends to 0 plus e raised to x plus e raised to minus x minus 2 upon x square plus a. Okay, now this e raised to minus x, I can write it as 1 upon e raised to x, right? Okay, now cross multiplying, you will get e raised to x into e raised to x, so the power gets add up, so you'll get e raised to 2x plus 1 minus 2 e raised to x, okay, upon e raised to x into x square plus a. Now this term we can write it as, this is our 1 minus e raised to x the whole square. Okay, if you expand it, you will get this same term. Okay, so this will be 1 minus 2 e raised to x plus e raised to x the whole square, which is e raised to 2x. So this is the same term, so we can write it as limit as x tends to 0 plus 1 minus e raised to x the whole square, okay, upon e raised to x into x square plus a. Now we know this term, that is 1 minus e raised to x upon x will give you 1 for limit as x tending to 0. Okay, so this is your log e. So by substituting limit formula, so we'll get this as, this becomes 1, so 1 upon e raised to x, which is e raised to 0 is 1, so we'll get 1 plus e. Okay, so this is your RHL. I'll write it here. Let's find out LHL. Okay, LHL is this, so left hand limit as x tends to 0 minus. Okay, now here b 1 minus cos x, 1 minus cos x you can write it as, using the half angle formula, you'll get 2 sin square x by 2, right, upon, for this you have to rationalize, so 1 plus x square minus 1, 1 plus x square plus 1, 1 plus x square plus 1. So multiplying this, that is a minus b, a plus b, a square minus b square, you will get limit as x tending to 0 minus b into 2 sin square x by 2 into root 1 plus x square plus 1 upon this square, so 1 plus x square minus 1, so you will get x square. Okay, so again we have to do the same thing, that is we have to make the angle equal. So here we have already x square, we have to make this angle as x square by 4. Okay, so dividing by 4, multiplying by 4, this term becomes 1. Okay, sorry, so this term becomes 1. Now you can cut this 2 ones are 2, 2 2s are 4. Okay, now taking x tending to 0, so limit as x tends to 0, this term is 0, right? So 1 plus 0 is 1, root of 1 is 1, so 1 plus 1 you will get 2. Okay, and this becomes 2, right? I'll remove the limit sign, so this is 2, this 2 and this 2 gets cancelled, and you will get here final as b. So our LHL is b. Okay, now the function is given continuous at x equal to 0. Okay, function is continuous at x equal to 0. So RHL is equal to f of 0 is equal to LHL. So RHL is 1 plus a. Okay, okay, so here the direct answer is not given. X equal to 0 we have to find out, that is at f equal to f of 0 is putting the value of x equal to 0, you will get it as minus 1, right? So RHL is our 1 plus a equal to minus 1, so a equal to minus 2. Then b, LHL equal to minus 1, so b equal to minus 1. Okay, in this question you have to find a and b, and f is given continuous at x equal to 0. Okay, now this function is for left hand limit because x is less than 0, this is for right hand limit x greater than 0. Okay, so let's solve our LHL limit as x tending to 0 minus, okay, log 1 plus 3x upon x minus b. Now this is log 1 plus 3x upon x, so this is of the form log 1 plus kx upon x, which we can write it as limit as x tending to 0 minus log of 1 plus 3x raised to 1 by x. Okay, and using the limit formula it becomes log e cube, right? Because whenever we take log 1 plus kx 1 by x, this is log e raised to k, which is nothing but k. Okay, so the final answer is 3. We'll write it as, putting the limit you will get this as log e cube minus b, which we can write it as 3 log e. Log e is 1, so 3 minus b. This becomes your LHL. So I'll write it here. Okay. Let's find out RHL. Right hand limit as x tends to 0 plus e raised to sine ax minus 1 upon x. Okay, so whenever the term is with e raised to something, we need in the denominator also that term. Okay, so I'll just multiply x, I'll write here sine ax, okay, into sine ax. Okay, so e raised to sine ax minus 1 upon e raised to sine ax. So this term, when we put the limit extending to 0, it becomes log e. Okay, and this x I can write here. Okay, but we need here a also, so into a divided by a into a you have to do. So this term also becomes 1 when x tends to 0. So the final is a. Okay, so our RHL is a. Okay, now the function is given continuous. Function is continuous at x equal to 0, but here f of 0 is not given, that we have to find. So f of 0, this term directly becomes 0, right, when x we put as 0. So this is 5, f of 0 is 5. So LHL is equal to RHL is equal to f of 0. So LHL is our 3 minus b equal to 5. So b is equal to minus 2. Okay, and a is equal to 5. These are the answers. Let's solve this. Now this function is defined on an interval. Okay, and the interval is 0, 6. Okay, and this interval is split into these intervals, that is 0 to 2, 2 to 4 and 4 to 6. Now we have to make use of continuity on an interval. Okay, now if you see these functions, okay, now here the left hand limit is 0, right hand limit is 2. Here left hand limit is 2, right hand limit is 4. Now this left hand limit and this right hand limit is equal because this function is given continuous on 0, 6, that is the closed interval 0, 6. Okay, again we have to make use of right hand limit on 4 and left hand limit on 4. Okay, so it is continuous at x equal to 4. Okay, so this function is continuous on the interval 0, 6, closed interval 0, 6, which implies, and from this we can write f is continuous at x equal to 2 and x equal to 4. Okay, let's write down the left hand limit at limit x tending to 2 minus, okay, left hand limit. So we have to consider this. So x square plus ax plus b. So we'll get directly, you have to substitute the value of 2. So 4 plus 2a plus b. Okay, then RHL, that is right hand, sorry, this is your RHL. Okay, because it is here. No, this is less than 2 now. This is left hand it is. Okay, because we are considering it less than 2, and here we will be considering greater than 2. X is between 2 to 4, so equal to 2 and greater than 2. Okay, so this is your RHL. Limit as x tending to 2 plus. Okay, for that you have to consider 3x plus 2. So 3 to the 6 plus 2, it is 8. Okay, so we can take the information, that is f is continuous at 2. So we can write f is continuous at 2. So this LHL is equal to RHL. So 4 plus 2a plus b is equal to 8. Okay. So we'll get one equation. 2a plus b equal to 8 minus 4 is 4. So this is your first equation. 2a plus b equal to 4. I'll write it here. Okay. Now you have to go for continuity at 4. Okay. Now this is less than or equal to 4. So for less. So LHL. Limit as extending to 4 minus. Okay. You have to consider this limit, this function 3x plus 2. So 3 4s are 12. 12 plus 2, 14. Okay. RHL for right hand limit, you have to consider the x which is greater than 4. So this 4 plus, so substituting the value of 4, 4 to the 8, 8a plus 5b. Now taking the information that is f is continuous at x equal to 4. This right hand limit and left hand limit equals. So we'll get 8a plus 5b equal to 14. So this is our second equation. Now you have to use elimination method to find a and b. Okay. So I'll multiply this term with 5. Okay. 5 2s are 10. 5b 20. 8a plus 5b 14. So elimination method, minus minus minus. So we'll get 2a, and this is 5 6, sorry. So a is 3. Okay. Substituting in first equation, you will get 2 3 is 6. 6 plus b equal to 4. So b is equal to 4 minus 6 minus 2. Okay, so this is the answer.